So good morning all. Today let us see a topic in dental materials which is casting defects. Okay. So what is a casting defect? Any error in the procedure of casting which is going to result in a defective casting, you call it as a casting defect. Okay. And these casting defects, you can classify them into various types. And Phillips has classified it into distortion, surface roughness and irregularities, porosity, incomplete or missing details. And then based on the location, he has again classified this defects into internal and external. Right. So now let us see about each defect a little in brief and how to minimize it. So first is distortion. So distortion mainly occurs because of the distortion of the wax pattern. Okay. So it can occur from the time of wax pattern preparation to the time of investing, mainly because of the stress relaxation from the wax. Okay. So distortion of wax pattern usually occurs during the investment procedure. So how you can minimize it is you have to apply as much minimum pressure over the pattern as possible, and you have to manipulate the wax at a high temperature, and you have to immediately invest it. And if you have to store it, the wax pattern, if you're not able to invest it immediately, you have to at least store it in a refrigerator. Okay. So the next defect is surface roughness and irregularities. So surface roughness is mainly defined as finely spaced surface imperfection, either in height, width, direction. Okay. Next, surface irregularities. So these are isolated imperfections, which can be in the form of nodules. Okay. And they don't characterize the entire surface. Yes. Now, the surface roughness of the casting is greater than the wax pattern from which it is made. Naturally, any surface irregularity which is in the wax gets manipulated in your casting. Why? Because of the particle size of the investment and the ability to produce the pattern, to reproduce the pattern in microscopic details. Okay. So the next defect is air bubble. So air bubbles are nothing but small nodules which you can see on the casting surface. And these nodules get attached to the surface during or subsequent to the investing procedures. Okay, because of the air that gets entrapped inside. So how you can prevent is you have to follow a proper investment technique. You have to do proper vibration of mix or proper vacuum mixing so that there is no air which is getting entrapped inside. Fine. And you have to apply the wetting agent properly. As soon as you fix the wax pattern inside the ring, you will have to apply the wetting agent over the wax pattern so that the investment will flow nicely over your wax pattern. Yes. So next is water film. So any water which is left inside can be seen in the form of fins like this. Okay. So these appear as ridges or veins. So this again you can prevent it by applying the wetting agent properly, using the correct liquid powder ratio as given by the manufacturer. Yes. And these fins and spines on the castings can sometimes occur, and this is mainly because of the flaking of the investment. So when you have flaking of the investment, it creates micro cracks through which the molten metal can flow through. So what you have to do is you have to heat it gradually, at least 60 minutes from the room temperature to 700 degrees Celsius. And more the bulk is, more slowly you have to start heating. Okay. And sometimes underheating can also be a cause for the casting defect. Why? Because when you underheat it, the wax residue is not eliminated completely. Okay. And the prolonged heating will also be a cause for defect. Why? Because of the disintegration or decomposition of the investment. Okay. And because of which numerous sulfurous compounds get released, and they just coat on the surface the sulfurous compounds. They prevent the casting from responding to the pickling. Okay. So next is foreign bodies. Any foreign bodies which get lodged within the investment, like some pieces of investment or bits of carbon which is derived from the flux, or any sulfur components which are released because of overheating. So all these act as foreign bodies, and these can also be the cause for the casting defects. Next is pattern position. The wax pattern, how you place it inside the investment ring, casting ring, is also very important. Should see to it that you are not placing two wax patterns too close to each other, and you can't place all patterns in the same plane. You have to change the plane and keep, and at least 3 mm of gap should be there between the adjacent uh, patterns. Yes. So the another cause is impact of metal alloy. So when the molten alloy, when there is a direct impact of the molten alloy, especially on the weaker portion of the mold surface, so that can cause fracture, or it can abrade the mold surface. Okay, how much of a bulk it is. So what you have to do is always do a proper sprueing, and you have to place the sprue at a 45-degree angle and not at a 90-degree angle. And carbon inclusions, which come either from the carbon crucible or from the investment or your torch, which you have not adjusted properly. So all these can be the cause for the carbon inclusions, which again can be a cause for the casting defect. Okay, so next is porosities. Now this porosity again has a wider classification. You can classify these porosities into three types: the porosities which occur because of solidification defects, porosities which occur because of the gases, and porosities which occur as a result of air which is trapped in the mold. Because of solidification defect, you have three different types of porosities, which are localized shrink porosity, suckback porosity, and microporosity. And based on the gases, you have pinhole porosity, gas inclusion porosity, and subsurface porosity. And the air which is trapped in the mold gives rise to back pressure porosity. Okay. So let us see about each in detail. So first is localized shrinkage porosity, which is occurring as a result of solidification defect. It occurs mainly because of the premature termination of the metal during solidification. So you can see here that the metal has not reached till the end, especially at the sprue casting junction it occurs. So why it occurs? Because the diameter of the sprue is too narrow, so the metal has not reached till the end, or the length is too long. Okay, or you don't have a reservoir, or the direction of sprue is at exactly 90-degree angle. All these could be the cause for localized shrinkage porosities. So how you have to prevent this? You have to place the sprue at a 90-degree angle. You have to give a minimum space of 6 mm, okay, from the end of the casting ring to the superficial surface of the wax pattern. Okay, and the sprue has to be attached to the thickest portion of the wax pattern, and see to it that you're flaring the sprue at the point of its attachment to the wax pattern. Okay, and you have to place a reservoir. A reservoir can be placed. This is a reservoir. So a reservoir can be placed close to the attachment. Yes. So all these are ways by which we can prevent localized shrinkage porosity. Next is suckback porosity, which is seen as an external void on the inside of the crown opposite to the sprue. Okay. So this is mainly due to the hot spot which gets created by the hot metal which is impinging on the mold wall near the sprue, because it is this hot spot which is the last to freeze. Okay, this region is the last to freeze, and since the sprue is already solidified, okay, so sprue, if in case gets solidified earlier when compared to a hot spot, you won't have any further molten material available to fill up this hot spot. So what happens is a shrinkage occurring in that region, which you call it as suckback porosity. Okay, so especially in the occluso-axial or the inciso-axial line angles, you get this type of porosity. So here you can see at the junction of the sprue and the wax pattern on the inside of the sprue, you will get this type of defect. So what you have to do, or how you can prevent, is you have to do a flaring of the sprue at the junction of the sprue to the wax pattern, and reduce the temperature between the mold and the molten alloy. There should not be too much temperature difference between the mold and the molten alloy. Okay, so then you have microporosities, which are fine irregular voids which are seen within the casting because of the rapid solidification of the alloy when the mold or casting temperature is too low. Because when the temperature is too low, they solidify very fast, and because of that you can have microporosities. Okay, So the other porosity is pinhole and gas inclusion porosities, which again occur as a result of entrapped gases. Okay, both are almost the same except for the fact that the gas inclusion porosities are much larger, and most of the metals we know absorb gases, and when you melt them, these gases, they are expelled. Okay, so the for example, copper and silver dissolve oxygen, platinum and palladium dissolve hydrogen. Okay, so also by the gases which get occluded from the poorly adjusted flame. Okay, or you're using an oxidizing zone instead of a reducing zone. So all such could be the causes of the pinhole and gas inclusion porosities, and the casting, okay, is usually black. Okay, so in such cases, your casting will also be black, and they don't just get cleaned up by pickling. Okay, so then you have subsurface porosity, which is caused by simultaneous nucleation of the solid grains and gas bubbles at the first moment that the alloy freezes at the mold wall. So as the alloy starts freezing at the mold walls, you have a nucleation of all the grains and gas bubbles. So all this can again result in a porosity which is called subsurface porosity. So what you have to do is you have to control the rate at which the molten metal is entering the mold. Okay, so that could to some extent prevent the subsurface porosity. Next, you have back pressure porosity because of the air which gets entrapped inside, okay, especially on the outer surface of the casting. And this occurs because of the temperature which is too low. Okay, and the casting or the mold temperature is too low. What happens? It solidifies very fast, and when it solidifies very fast, all the air which is trapped inside will not be able to escape out. Okay, so you have, for this what you have to do, you have to have a sufficient casting pressure, and proper burnout has to be done so that all the wax is getting eliminated. Okay, and proper liquid powder ratio has to be there, and also the thickness of investment between the tip of the wax pattern and the end of the ring should be 6 mm and not more. What happens when the distance is more, the difficult for the air which is entrapped inside to escape out through that longer path. Yes. So the other defect you can see is incomplete casting. It can be because of insufficient venting, insufficient pressure, incomplete elimination of wax, or you have not used proper liquid powder ratio of your investment, or your fused metal is too viscous, or the sprue is being blocked because of some foreign bodies or other contaminations. Okay, or some gases have occluded inside. So all these could be the result of incomplete casting. So instead of a casting like this, you get a rounded castings like this. So this could be the causes. Yes. So sometimes we can have a too bright and shiny casting naturally because incomplete elimination of wax is there. And sometimes you have smaller castings. This mainly occurs because of the inadequate expansion of the mold cavity and the shrinkage of the impressions. So again, liquid powder ratio has to be taken care of to avoid such problems. And you have black casting sometimes because of the release of sulfur as a result of incomplete wax elimination or overheating. Okay. So now let us see a few questions which have been asked in relation to this casting defects in the past few years. The first question is glossy smooth margins of the casting. So the glossy smooth margins of the casting, naturally I told you it's because of the incomplete wax elimination. Second question is subsurface porosity can be decreased by, I told you subsurface porosity occurs mainly because of the nucleation of the solid grain. So how you can control is by decreasing the sprue thickness. Okay, so you decrease the sprue thickness so that the molten metal is reaching the entire region. Okay, so and I told you subsurface porosity is because of rapid entry of molten metal into the mold. So subsurface porosity is reduced by increasing the sprue length and by reducing the sprue thickness and mold metal temperature. Okay, so the sprue length has to be larger enough, and the sprue thickness has to be smaller. So when you have a smaller thickness of a sprue and an increased sprue length, the rapid entry of molten metal into the mold space is prevented. Okay, and as a result, the subsurface porosity can be decreased. So the answer is option B. You have to increase the sprue length, decrease the sprue thickness, and decrease the melting temperature. Okay, so the answer is option B. The third one, back pressure porosity. So this back pressure porosity can be avoided by using asbestos liners. No. Placing the screw at least 1/4 inch away from the end of the ring so that you have the space for the air to escape. Okay, so answer is option B. Preventing rapid heating of the investment in the burnout oven using a short and a wider sprue. Yes. So for back pressure porosity, which occurs mainly because of the air which is trapped inside, the answer should be option B, where you keep it at a 1/4 distance away from the end of the casting ring. Okay. Air bubbles formed on the surface of casting. So why air bubbles form? Mainly because you have not used the wetting agent properly. Okay. So improper wetting of the wax pattern by the investment will give you air bubbles on the surface of casting. Next, disadvantage of having a short sprue. The sprue is too short. What will happen? You will not have that space of 6 mm between the end of the casting ring and your tip of the wax pattern, so the gas will not evacuate. So incomplete evacuation of gases will occur because of the short sprue. So answer is option C. Next is suckback porosity. So suckback porosity, I told you it mainly occurs because of the hot spot which gets created and the sprue solid, there is no any reservoir present. So there is no any molten metal to reach this hot spot. So it's this hot spot which is the answer for suckback porosity. Next, gases dissolved in molten metals are liberated when cooled, giving rise to. So the answer is gas inclusion porosities. So the gases which are trapped inside will give rise to gas inclusion porosities. Okay. So in short, if you see, uh, you have a suckback localized shrinkage porosity. The main cause of this porosity is shrinkage of the molten alloy on cooling due to premature termination of the flow of molten metal during solidification and irregular voids in the casting. So all this you can prevent the suckback porosity by using a thick sprue, by placing a reservoir and by flaring the point of attachment, okay, and attaching the sprue at the thickest portion of wax pattern. So all this will prevent your suckback porosity. Next, I told you is back pressure porosity. This is mainly because of the air which is not escaping out properly. Okay, and how you can adjust this is how you can prevent this back pressure porosity is by maintaining a 1/4 inch distance from the tip of the casting ring to the tip of the wax pattern and using sufficient casting pressure and proper burnout has to be done so that all the air which is trapped is escaping out. Then I told you pinhole, subsurface, and gaseous inclusions, porosities. So all these mainly occur because of the rapid entry of alloy into the mold. So there's no time for the gases which are inside to escape out because the molten alloy enters and gushes in a very fast manner. So what you have to do is you have to avoid overheating, avoid prolonged heating, and use a long and a thinner sprue. So this will prevent the rapid entry of alloy into the mold. Next is you have microporosities. These occur because of rapid solidification, shrinkage. So what you have to do is you have to increase the melting temperature. So increasing the melting temperature will prevent microporosities. And then I told you you have incomplete castings also because of insufficient melting or highly viscous molten alloy, or in other words, molten alloy. You have not, the temperature is too low, or you have not eliminated the wax properly. So to prevent all that, you have to do proper, give proper venting, give proper pressure, and do proper burnout, and give proper heat for the melting of alloy. So all these will prevent your incomplete castings. Yes. So hope you have understood the basics about casting defects and porosities and how you have to prevent these defects. Yes. So thank you for your patient listening.